This is Algebra 1B, Part 1, Unit 2 sample work. It is vocabulary, so I'm going to walk through the lessons. Basically what you do is when you see key words in the lesson, you'll see them below the objectives, usually on the second slide of the lesson. You write down the key word, write the definition, and then sketch an example or give an example, a specific example. Okay, so let's go ahead and get started. The first key word is exponent. Exponent. Okay, an exponent is the number that says how many times to multiply the base by itself. Here's my example. 2 to the third equals 2 times 2 times 2. 3 is the exponent. Notice that 3 does not appear in the expansion of 2 times 2 times 2. It just tells me how many 2's to write. Exponent. Next word, exponent of 0. Okay, when an exponent is 0, the result is 1, with one noted exception. So 2 to the 0 power literally means 1. Here's the reason. It means 2 to the 1 divided by 2 to the 1. 1 minus 1 is 0. And anything divided by itself is 1. So anything to the 0 power is 1. The exception is 0 to the 0 power is not 1. Okay? You can't raise 0 to the 0 power because that would involve dividing by 0, which is not allowed. Okay? But anything to the 0 power is 1. Exponent of 0. Negative exponent. Negative exponent. Okay? A negative exponent means repeated division. Remember, an exponent means repeated multiplication, but a negative exponent means repeated division. So 2 to the negative third is 1 divided by 2 to the third. Okay? Another way to think of it is you can move a base with a negative exponent across the fraction bar, and the negative exponent becomes positive 2 to the third. Okay, that's it for Lesson 1. Let's go to Unit 2, Lesson 2, Scientific Notation, and see what key words there are for us there. One keyword, scientific notation. Scientific notation. It's a method for writing long numbers short. A method for writing long numbers short in the form a digit, a decimal, any number of digits, times 10 to some power. Examples. I'm going to give two examples here. 1,780,000 is 1.78 times 10 to the 1, 2, 3, 4, 5. And 0.000253 is 2.53 times 10 to the negative 1, 2, 3, 4. Negative 4. Notice that negative exponents are for small numbers because they involve dividing by 10. Positive exponents are for big numbers because they involve multiplying by 10. Okay, that's lesson 2. Let's see what else there is. Lesson 3, multiplying powers of the same base. Let's see what keywords there were. Oh, there's a few. And there's some repeats, so if a word appears twice in a list, you do not need to define it twice. Okay, base. We use the word base here. The number multiplied in a power. So in our example, 2 to the third equals 2 times 2 times 2. 2 here is the base. Exponent we already defined. Power, I just used the word power, so we need to define it. A base with an exponent. So 2 to the third power, the whole expression is called the power. And scientific notation we already defined. So we do not need to define that again. Okay. Lesson 4, multiplication properties, more multiplication properties of exponents. Keywords, base, we defined. Exponent, we defined. Power, scientific notation, we defined those already. There won't be any keywords in unit reviews here. Okay, but lesson 6, division properties of exponent. Base, exponent, power, scientific notation, we've already defined those. Lesson 7, exponential functions. Okay, and there's a keyword. The new keyword there is exponential functions. It's a function with x as the exponent, or any variable technically. Example, f of x equals 2 to the x. That's an exponential function. It means to multiply by 2 repeatedly. Okay. Lesson 8, exponential growth and decay. Okay, we've got quite a few words here. So let me make some more room. Elbow room, cried Daniel Boone. Okay. So here we go. Compound interest. Interest that adds to the balance. or total. Okay? Increasing it. So an example of compound interest, the amount in account is principal times 1 plus the interest rate, the AYP, divided by the number of compounding periods to the power of NT. Okay? Compound interest. Decay factor. A base in an exponential function that is between 0 and 1. Okay? Example, 4% decay means the base, B, is 100% minus 4% equals 96%, or B equals 0.96. So we would write Y equals the amount in the account, let's say it's $1,000, times 0.96 to the x. That would be an account in decay, or an exponential decay formula. Decay factor. And next word, exponential decay. When an exponential function decreases, example, right there, y equals 1,000 times 0.96, the graph would look something like this. Okay. Exponential decay. Exponential growth. When an exponential function increases. Example, y equals 1,000 times 1.04. Because we're multiplying by 1.04, something bigger than 1, this is going to grow. And the graph will look something like this. And growth factor. A base that is greater than 1. Example, B equals 1.04 is a growth factor because it's bigger than 1, causing the function to grow. All right, so that's Unit 2, Lesson 8. Let's see what else there is. Oh, then there's the unit review and the test. So that is the last word. All right.